Let's now spend some time looking at area and perimeter as it pertains to circle. Beginning with circumference. Circumference means the perimeter of a circle. Think of the distance or the length around the circle, or the path to walk a circle. The arc length is just a portion of the circumference of a circle, portion or part of a circle, like the length of a curved fence if you were fencing in like a circular garden or something like that. A sector of a circle is the region bounded by two radii of the circle and their intercepted arc. Think of a pizza slice. Think of a slice of pie. A sector of a circle is like a section of a circle. There's a sector of a circle. So when it says bound by two radii, so from the center there's one radius and another radius and the intercepted arc. There's the intercepted arc. So that gives us our little pizza slice or slice of pie. We're going to find the area of sectors and the length of the arc from a sector in the following examples and use them to find other things. Example 3. Find the area of the sector that is shaded. So we go to our formula sheet and we look for circle and we find the area formula for the circle. So we write that down. Area equals pi radius squared. If we don't remember that r means radius, it's shown in the picture as the length from the center to a point on the circle. So if we were finding the area of the entire circle, we would write pi, and then the radius is 3 squared. However, that would be the entire circle. We only want this section, this 70-degree section. Well, we know to go all the way around a circle, that's 360 degrees. If this is only part of it, to take part of something, we're going to do just a portion of 360. 70 3/60ths is all that we want of this circle. So we multiply by the angle that we have of that sector divided by 360. Let's go to our calculator now and find out approximately how much that makes. If we're rounding to the nearest tenths place, we would write 5.5. The units are feet, and because this is area, it's square feet, or feet squared. Number 4, the area of the shaded sector is 49.1 square centimeters. Find the area of the circle. So we're given the area of just this shaded part. Now notice first of all that the 135-degree angle is given for the white part, the unshaded part. So let's first find out how many degrees is the shaded part, because that's usually what we need. So 360 is the entire way, minus 135. 225. 225 degrees is that shaded portion. Now, we know area and we know we're dealing with a circle, so we're going to say area is pi times radius squared. But they already gave us the area of the circle. The sector. We just need to find out the entire circle. So instead of needing a formula because they already gave us that area, we just have to work backwards and say if 49.1 is the sector, I want to get to the entire circle, so I want to make it bigger. So you know here how we multiplied by the degree of the sector divided by 360? Well, now we do the opposite. We divide by it or multiply by the reciprocal. 360 divided by 225 degrees, the angle in our sector, the central angle of our sector. Let's go to our calculator. We get exactly 78.56, and because it's still area, we say centimeters squared. That's the same as square centimeters. Let's look at a couple more. Find the arc length of AB. So we remember that arc length means the circumference, but just part of the circumference. So we go back to our formula from our formula sheet, and we see that we need to use the circumference formula. Now, there are two circumference formulas depending on if we have the radius or the diameter. In this picture, I have the radius, so I'm going to use the circumference formula with the radius. C equals 2 pi times radius. So in our picture, we'll use 2 pi times 6, but again, we only want this length right here. How much of the circle is that? Not the entire 360 degrees, just 135 degrees. So like we did earlier, we say times 135 over 360 to get just part of that circumference. Now we go to our calculator, and that's approximately 14.1. My units are feet, and it's not area, it's just a length, so it's just feet. Number 6, find the circumference of circle D. What did they give us this time? 4.19 inches. They put it on the outside of the circle, which means it's just for this length. This is the arc length, 4.19 inches. So this is part of their circumference. But like that area problem earlier in number 4, we're already given the arc length. We don't need to find it, we just now need to find the entire way around the circle. So our circumference, our arc length, to get to the entire way around the circle, we're going to do like what we did here, but multiply by the reciprocal, 360 divided by that central angle, or that arc measure, 40 degrees. Now we go to our calculator, and that's 37.71 inches.